Welcome, everyone. I'm Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. Hello, everyone, and welcome to our session today, Planning 2026 with Google Gemini, how AI-powered insights can drive your strategy. Presenting today's topic is Geetika Sethi. Geetika is a seasoned professional with over 10 years of experience in research and teaching. She specializes in GCP data analytics, covering data lifecycle management, solution architecture, and data visualization using Looker Studio as well as other tools. Her expertise extends to ML AI-driven analytics, focusing on prediction, automation, and pattern recognition. She has successfully delivered numerous corporate and academic trainings with excellent outcomes. Please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Cloud Practice Area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. In this masterclass, strategy, finance, product, and data leaders will learn to turn to enterprise data into decision-ready briefs, what-if scenarios, and action plans using Google Gemini, grounded by BigQuery Plus documents for cited trustworthy insights. Synthesize signals into concise memos, model demand pricing cost scenarios with assumptions and risks, and capture next steps in Docs Sheets chat. We'll also cover multimodal inputs, lightweight evaluation loops for quality cost latency, and guardrails and access controls so outputs are audible, governed, and ready for 2026 execution. I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handouts section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey, Geetika, thank you so much for joining us today.
Hi, everybody. A very warm welcome. Please allow me to introduce myself as Dr. Girika Seti, an AI researcher. Today, we are going to gear up to work on planning our 2026 with Google Gemini. The core of this knowledge sharing would focus on how we can implement AI-powered insights that would help drive our projects strategically. Moving forward, the agenda of this webinar is going to be looking at the introductory information in which we would look at the core examples where AI-powered systems have provided insights successfully. Followed by this, we would look at the building blocks to be prepared for AI-based systems that can be built to help design the strategy of the ongoing important projects in our organizations. Then we would move to the life cycle of AI-powered insights across the different implementations. And then we will look at how to actually operationalize these insights. The core important implementation of responsible AI systems cannot be ignored or neglected. These are the heart and soul of AI implementations to serve mankind to the bestest of possibilities. And then we will look at a real world scenario where in different phases a project can be designed to implement AI-powered systems to strategize the projects and gain from the same. So let's move forward to the first foundational and introductional information that is going to provide multiple examples where AI-powered systems have been successfully implemented in the real-world scenario. The first example includes the retail industry, where the inventories can be adjusted based on the real-time demand. And the best example in today's world would be our e-commerce web applications that have to adjust to the real-time demand, for example, during Christmas time, when the demands surge, the organizations, the companies have to adjust their inventories to fit into the same. Such implementations can benefit from AI-powered systems to avoid business failures and ensure the revenues are boosted well accordingly being adjusted to the demands. Another example that is a clear-cut successful implementation of AI-powered systems involves the banking industry that offers multiple products where the risks have to be predicted in advance. The simplest example would be the loan application approval, which needs to come along with timely risk indication for a given loan applicant. So the bank managers and the stakeholders leverage AI-powered systems to predict such risks in advance. and take the decisions accordingly. The next example is one from our day-to-day lives, an example that empowers our lives and lives of a common man on daily basis. And that includes the ride-sharing platforms. And we all, at some time or the other, leverage such platforms typically, where we would love to have our driver allocated for our ride instantly without delays. Such optimizations involve big time the AI powered systems. Another example which we routinely come across is the media industry, where the content personalization to the user choices in real time is very well backed up by the AI systems. This implementation heightens the user engagement, which offers high traffic rates to the websites and the static content or the dynamic content that the media companies offer to the user base across the globe. The last but not the least is the manufacturers, who are able to respond quickly and timely to the supply chain disruptions because of the timely intimations that come through because of the AI-based systems or AI-powered systems. So across the globe, different businesses, different industries, different domains are leveraging the power of AI systems, as we could see through these examples. And these systems are imperative in digital age today, which is 2025, and heading on to 2026 would be even more important to have competitive edge in the market and to ensure the revenue streams or the business revenue streams are totally uninterrupted. Moving to the next implementation, we are going to look at defining these AI-powered insights. So what are these AI-powered insights actually that help these businesses grow, maintain, overcome the challenges? So the list of such insights is as follows. The first example are the predictive models, where we would love to forecast a lot of things, including the customer purchase behavior. This forecasting of the customer purchase behavior allows organizations to be providing recommendations to these customers and ensure that the customer is served well, as much as ensuring the business revenue outputs. The next example of the AI-powered insights that are leveraged across the globe by different organizations includes prescriptive analytics. Here, the recommendations come up through AI systems based and powered by credible data systems for optimal marketing actions. And these marketing actions are not only optimal, but also timely, so that the opportunities and the capturing of the market opportunities is performed in a timely manner. The third example of the AI-powered insights that benefit organizations are the NLP systems. big, big time, the natural language processing systems, they are able to help the organizations for the use cases like summarizing customer complaints in an automated manner. Another example would be the chatbots, where NLP systems are highly leveraged to help the customers in a super quick manner, serving the customers for their queries in a super quick manner. Followed by NLP systems, another domain which serves the businesses super well is the computer vision, which is another powerful domain in AI systems that help detect the anomalies or issues based on the imaging data. So the imaging data of the products are fed to the computer vision based AI systems that can detect the defects in these products at the factory level itself. These defected products are then stopped from reaching the customers, thereby powering the business and preventing the damages that the business can face. And the last example, which is highly implemented across the globe and for which sky is the limit, are the machine learning algorithms. There is no upper limit to which these algorithms can be leveraged and are actually being leveraged across the organizations for different use cases, with one example being anomaly identification in financial transactions to, to predict the fraudulent transactions in advance and to prevent the harm that the business can face from such fraudulent transactions. So far, we have seen the examples of how the AI powered systems can add success to a given business. Then we looked at the list of such AI powered systems. And now we are heading forward to the next understanding where we see the core examples where artificial intelligence serves to be an engine of the adaptive strategy. And these strategies that are adopted by these domains, typically like healthcare domains, where the healthcare providers use these systems as the assistant tools. I repeat, where the healthcare providers use these systems as the assistant tools that help determine the care pathways in the dynamic manner. But these do remain merely for assistance purposes only. Another example where artificial intelligence based systems serve to be the engine of the strategic implementations for successful outcomes are the telecom companies, where the network load is optimized typically using AI predictions, thereby addressing a big challenge that these companies face altogether. Hence, the employees, the workers are able to use these systems as their assistants, or they get assistance from such tools to be empowered and have high productivity and efficiency at their work. Next, we look at the core pillars to be ready with such powerful AI systems. And what are those foundational elements which are inevitable and are the building blocks for getting such systems in place. So the first and the most important pillar is the data. And the data is totally inevitable to build such systems. One use case would be looking at the strategic alignment where the AI-powered lead scoring helps to boost sales from converting the leads to the sales actually. So this conversion of the lead to actual sale gets a boost typically from the existing AI systems that the organization adopts. Another example would be looking at the predictive maintenance for reducing the operational costs altogether. So the timely predictions on the maintenance requirements help lower the costing at the last minute maintenance issues that may crop up in the working and the pipelines of the organizations. The last example where the strategic alignment with AI systems help achieve customer satisfaction and thereby improving the operations would be having the automated quality control into place. So one example would be going back and ensuring that at the factory level itself, the default or the products that are not up to the mark are handled and removed or taken care of at the factory stage itself. By improving the quality control through such automated systems helps improve overall customer satisfaction. So these AI systems that are built for the outcomes that we've already discussed are built on the core pillar of an instrumental element, and that is data. So one of the approaches to deal with the data implementations would be to create a unified data lake to integrate the siloed data sets. And these integrated data sets are then channeled to build the powerful AI systems. Followed by this, it is mandatory to ensure the data sets which are being channeled to the AI systems are the high quality data sets. Therefore, implementing data quality checks is mandatory for achieving the accurate analytics, like the predictive analytics we discussed in the previous slides for the AI-powered systems. Also, we want to ensure that the metadata for the data sets is well defined so that down the road, audit compliances can be in place. Having defined the data sets that would be implemented in our AI-powered systems, we then have to ensure that the implementation of those data systems is well within the data governance, or in other words, the frameworks and the rules and the policies of a given organization in order to maintain the outcomes trustworthiness, or in other words, in order to maintain the trustworthy insights. So what we mean by this is that we implement the data sets which are mandatory and the foundational pillars of our AI systems. But these data sets are coming from sources or the repositories where right principles are followed for data management and data governance. This implementation is highly critical for the credibility of the systems and the accountability of the systems that are being built to leverage the AI algorithms and give the outcomes for the benefits that we've already discussed in the previous slides, followed by the data readiness and governance. Another foundational pillar is the infrastructure and scalability. So the data pipelines and the data implementations that we discussed in the previous slides would be the first set of inputs to build these AI-powered systems, followed by the data pipelines would be the need of the infrastructure inputs that would enable the advantageous implementations like low latency predictions for the use cases like the manufacturing use cases. So the point that we're trying to make over here is that preparing the continuous data ingestion pipelines with right data governance in place is the first input. However, this needs to be followed by the right set of infrastructural inputs, followed by the right scalability inputs that ensure the continuous integrations and continuous deployments leading to efficient pipelines. And the pipelines or the exemplary pipelines we are looking at are the machine learning pipelines as the examples of the AI powered systems. So overall, not only is the data set implementation, not only the data governance implementation, but also the infrastructural and scalable systems need to be in place to leverage the benefits to the maximum from the AI powered systems like the machine learning implementations or the MLOps pipelines in place. So overall, the goal would be to automate the AI powered systems with right set of inputs in place as shown in this slide. And the names of those inputs would be number one, credible data pipelines. Second, state of the art infrastructure. Third, scalable systems. And fourth, overall, these inputs allow the automated AI-powered systems to be in place. Hence, integration of all the inputs is critical in an efficient manner to achieve the benefits to the maximum. And it is the cloud platforms that offer all the inputs and integration of these inputs. The cloud platforms offer the services which can be leveraged to have each of these input in place and also each of this input integrated to build the efficient AI systems. Hence, it is important to emphasize that the multidisciplinary skill set is highly important for integrating all the systems that we have discussed in the previous slide. Human resources with different skill set pertaining to machine learning, data science, IT systems, mathematical and statistical evaluations, and most importantly, the domain and the business knowledge is now highly critical to ensure that the efficient AI systems can be built. Hence, multidisciplinary teams come together to achieve the powerful outcomes through these AI-based systems. Having looked at the inputs in the previous slides, now we want to be looking at the strategic life cycle and the implementation of the examples that highly benefit from the setup of these powerful AI systems. So the first core exemplary domain is the market strategy and gaining competitive advantage from the powerful AI systems that are built on efficient data pipelines, state-of-the-art infrastructure, scalable tools and technologies like containerization or through the Docker platform and orchestration through Kubernetes-based platform for overall building the efficient MLAI systems as we studied in the previous slides. So market strategy and competitive advantage is one of the feasible outcomes that can be achieved through successful implementation of the powerful AI systems built on the foundational pillars as discussed before. So let's take a look at how the organizations can get competitive advantage through right market strategy built based on the powerful AI systems. So let's take a look. So first example would be the brands predicting the upcoming shifts in the market demand, which is going to be a given trend in a particular season. So forecasting that really helps the retail industry and the brands associated to serve the customers accordingly. And such forecasting is built on the core analytics engine based on AI systems like ML ops, as we discussed in the previous slide. Another example would be sentiment mining, where the reviews of the customers are channeled to ML ops systems to extract insights from these reviews and feedbacks. Based on the insights that the AI systems reveal to the stakeholders, then the decisions are taken accordingly to strategize the businesses as per the customer reviews and feedbacks, and hence serving the customers in the bestest possible way. The third example is the dynamic pricing. So these examples that we're studying right now serve to be the detailed and exact use cases which are built on the powerful AI engines. So the dynamic pricing, which is a core feature of the e-commerce businesses, where the price adjustments can be done in real time to capture the sales as much as possible to impact the basket size of the shopping that is done by the users or the customers. So such adjustments which are made real time are powered by the AI engines based on the credible data pipelines, the state of the art infrastructure, automations, and efficient systems that are integrated all together to build the AI engines. Another example would be in the corporate world, where the competitor risk analysis can be predicted based on monitoring information regularly, which is the information that serves to be the signals that the company adopts and channels to the AI engines to make predictions for the upcoming risks from the competitors. This practice is highly prevalent in the corporate world at the back end, if not at the customer front, as opposed to the three examples that we have studied. This example is critical to the back end the strategies that the organization and company designs based on the insights from the AI engines. The last example that we discuss for the market strategy and competitive advantage is going to be the hospitality industry. Say for the residential provisions like the ones that come through the hotel industry, or let's say Airbnb, or any kind of temporary residencies or hospitality that is provisioned, the occupancy can be optimized, and hence can be the pricing that can be optimized. So if the real-time optimization of the pricing is done successfully, that can impact the overall occupancy of the places or the businesses offering the services or such services to the users. So what we are seeing is that the AI systems can power the outcomes in the domain of building marketing strategies and the providing the competitive advantage to the businesses overall. Of personalization ecosystem is highly prevalent in the world and era of social media, where the user data is channeled to the powerful AI systems and AI engines to leverage the information and strategize the personalized recommendations. One prevalent example in this area would be the e-commerce store, which have the capability to predict the customer churn risks typically. So these organizations and businesses can predict from the customer behavior the churn rates or the churn risks, and hence strategize their policies and implementations and operations accordingly. One example of the customer behavior that is studied to predict the customer churn risk would be the frequency of purchases that customer has done in a given duration. So based on this information, along with other complementary data and information, the customer churn risks can be predicted by the e-commerce companies, and hence the forecasting of their businesses and the position of their businesses can be forecasted accordingly. Next example would be the streaming platforms like Netflix, etc. They would be offering the content playlists to their customers after leveraging the insights from the AI engines. So the AI engines would process their user behavior and list the recommendations for a given user, and hence the tailored playlist of the content to a given user. This enhances user engagement, and the overall businesses are benefited as the customer is happy and engaged with the content of their choice. The next example is the telecom industry that overall provides the personalized upgrade plans. So the users who are purchasing the data plans on the given app of that telecom provider is continuously recommended with the right packages of purchases that can be done for the telecom use cases or the telecom uh, products that the customer is heading for purchase. So all such recommendations, be it telecom, be it travel apps, be it banks that offer the products, or be it the streaming platforms, or be it the e-commerce stores, these are all powered by AI engines, but those AI engines are in turn resting on the continuous data about the user behavior so that the pipelines can operate and the recommendations can be generated. So different industries and in different domains are able to plan on the customer strategy and personalization based on the user behavior data pipelines and the AI engines built on those pipelines. The last example of operational and supply chain efficiency in different businesses, be it airlines, be it logistics, be it hospitals, be it factories, be it grocery stores, the supply chain efficiency and the operational efficiencies are achieved through the predictive intelligence, which is implementing big time the AI powered engines. So let's take up a use case or at the grocery stores where the replenishment of the products which are sold out and the stocks to be maintained with the correct forecasting is achieved because of such predictive analytics through the AI powered systems. Another highly prevalent example would be the airlines industry, which performs the dynamic crew scheduling and adjusts the schedules dynamically based on the flight changes and regulations. So these systems are again powered through data pipelines. These systems are deployed on high-end infrastructure, and these systems are in place due to the built applications that involve high-end deployment systems of containerization through Docker and Kubernetes, and overall, the efficient AI systems are in place to cater to such use cases. And the last example, and highly critical, typically would be the healthcare industry, where the hospitals can forecast the patient volumes. And this use case is typically highly important in the post-pandemic era, having the world witness post-COVID how critical it may be to predict the patient volumes and prepare accordingly, thereby preparing not only for the business purposes, but also preparing for saving lives of the patients in an efficient manner and thereby serving humanity overall. So, having looked at the three important use cases of looking at the market strategy and competitive advantage, customer strategy and personalization, operational and supply chain efficiency as three core areas which leverage AI systems for building correct set of strategies. We now move towards the actual operations. So we looked at the foundational pillars of building the AI systems. We looked at the examples where these AI systems are leveraged to achieve outcomes, and very specific examples we looked at. Now we are looking at the operations of these AI systems to actually achieve the outcomes. So the first domain where the insights achieved from the AI powered systems are actually operationalized are the insight to action feedback loop. The goal over here is that the models that are in place, the ML AI models that are in place, they must be integrated into the workflows. And these models should be able to allow the insights which have the power to trigger the actions. So let's take a look at the examples where the insight to action feedback loop is possible. And this loop is possible only and only because the insights are arising from the AI powered systems. So the first use case would be, let's say, as we can see over here, would be, let's say, starting from the CRM tools typically, where the actions are triggered based on the churn scores. So churn scores are resulting from, let's say, predictive analytics. Churn scores are arising from the AI powered systems that are based on predictive analytics. And now the actions start to be aligned based on the insights of these churn scores. So the first action that comes into picture would be adjusting the procurement quantities automatically. So based on the churn scores, the procurement quantities would be adjusted automatically. So if the churn out or churn rate is higher, we would want to have the procurement quantities to be lowered. And on the other hand, if the churn scores are lower, we want the procurement quantities to be higher. So such adjustments are performed in an automated manner because the insights from the existing powerful AI systems are providing the information that trigger the downstream procurement systems accordingly. The next implementation in this complete feedback loop that we are studying as an example would be the updates that would happen on the dashboards of the stakeholders. So, number one, the insight. Second, the action due to the insight. Third, the update of these two is going to be done on the dashboards being routinely monitored by the stakeholders in the organization. So these teams, these stakeholders are updated about the actions, about the insights in a timely manner. And hence, they have their actions aligned and strategized accordingly. So, what we are seeing over here is that strategies exist at different levels, different domains, but those strategies are resulting because of the powerful AI systems in place. And let's not forget that powerful AI systems are in place only and only because of the input streamlined, credible data systems with within the data governance frameworks. Second, state of the art infrastructure that supports those AI systems coming through cloud technologies, for example, as private systems may prove to be cost inefficient. So cloud systems serve well and cater well to that. And the third input would be the scalable systems that allow the scalability to be in place to achieve the outcomes in the businesses, which are the targeted outcomes from these powerful AI systems. So coming back to our feedback loop, we go to the next implementation, that once the stakeholders are aware of the actions and the triggers based on insights, then they would look at their actions to be adjusted accordingly. And they would be also receiving the right set of insights and auto suggestions on the next set of actions that would fit the scenario well based on their actions, which would be the suggestions or based on the suggestions that are coming from the AI powered systems. Accordingly, the support teams in the organization would be alerted or empowered with the information about the upcoming tickets or customer uh, concerns that may come up, and hence they can prepare accordingly. So what we are seeing over here is that different departments, different functionalities, different verticals in a given organization can all operate in a feedback loop, which are based on insights to actions. And insights are provided and furnished by powerful AI systems, and actions could be automated. Actions may have human interventions as well, but they are all interconnected in a feedback loop for overall operationalization. So what we are looking at is the operationalization, which results from these powerful AI systems built on scalable systems and state-of-the-art infrastructure. Let's go to the next example where the operationalization of the insight is highly critical. And that example would be looking at the KPIs, the key performance indicators, typically. So the powerful AI systems that are in place for a given organization, those can be tracked, number one, for the accuracy. So the accuracy is a statistical outcome resulting from the models, say for example, the machine learning models that are in place to make the predictions and to give the insights. So how much can those predictions be trusted, and how credible are those predictions from the AI engines is dependent on the measures of these statistical outcomes like accuracy. There are other examples also. Not only the accuracy values are tracked, but there are other examples also like precision, recall, etc., which provide the measures of reliability of the predictions that these models provide. The next indicator, which indicates how successful the AI powered systems are in place, or how successfully the AI powered systems are helping, is that we would look at reducing the time to insight. Even for the feedback loops, we want the triggers, we want the insights in a timely manner. We do not want insights in a delayed manner. So the pipelines, starting from the data inputs to finally providing the insights through the AI powered systems, should be the ones which are low latency. Low latency means which provide insights in a reduced time and not in a delayed manner. The next indicator of success that the AI powered systems cater to in the businesses would be the cost savings and the budgets. So, due to the timely insights, timely actions, timely triggers, because of the highly accurate predictions and timely feedback loops that operate, ultimately the budgets can get impacted. And the goal would be to look at big time the cost savings that would come along with the efficient operationalizations of these AI systems. The next indicator would be the implementation of these AI based insights in a very customized and personalized manner as opposed to generic. The more personalized these insights followed by the AI engine implementation would be, the more customized outcomes would be possible to be achieved, which would in turn result in comparatively happy customers and the users being able to be impacted in a positive way. Users of the businesses being able to be impacted in a positive way. And the last and most important indicator is going to be the return on investment. So the net calculations after implementing the AI enabled initiatives would be to look at the benefits and the revenues that the businesses are able to fetch after implementing such AI enabled and AI powered systems for their complete operations within the organization for different realms, different verticals, for different departments, for different outcomes, be it front end serving the customers or be it back end, the operations that ultimately drive the full business altogether. So now we see that the AI systems that are in place and for which the indicators are being continuously accomplished and the success at these indicators is being accomplished, these AI systems need to be continuously reworked on. So once designed, these have to be continuously improved. They have to be improved for performance. They have to be improved for the outcomes, the insights, the accuracy in the insights. They have to be improved for the latency. They have to be improved for security. They have to be continuously improved for costing and the budgeting to make them highly cost effective continuously. So at the first stage of these improvements, the data pillar needs to be continuously improved for ingestion and adaptation. So for example, the recommendation models, which would be providing personalized recommendations based on user behavior, that user behavior data needs to be continuously updated. So that is one example of the stage, or one example at a stage where the data ingestion and adaptation needs to be in place real time, continuously updated. Let's say the data inputs are in place at the first stage of improvisation. In the next stage, the continuous forecasting needs to be refreshed with the seasonal trends. That means the exact outcomes that are being forecasted have to be also improved upon. So based on the trends, accordingly, the outcomes of forecasting predictions that are looked upon needs to be improvised. So let's say in season A, there was a set of forecasting that was set up through the AI powered engines. But in season B, these will have to be refreshed. Another set of forecasting would be needed that matches the seasonal trends. And the organization has to be prepared to make such jumps and to make such refreshing uh, forecasting models as opposed to sticking to the original outcomes and the forecastings that have been doing or that were being done previously. At stage 3, let us say, where having accomplished the updates of data regularly, having the right set of forecasting and predictions designed correctly in the timely manner, fitting with the trends of the market, trends of the choices of the customers. At the third stage, the monitoring of the model for the implementation uh, is extremely important. And monitoring of the model would mean monitoring of the complete AI systems that are in place. There could be one model, there could be multiple model, there could be complete model engine in place. There could be, let's say, single model implementation, there could be ensemble learning implementation, etc. So those the model implementations and the detections that the model is performing, that needs to be monitored on continuous basis. And let's say the model monitoring on continuous basis is being performed, then the model operations with training and retraining the models and retraining the models for with the data sets and updated data sets continuously would be again the next important stage. And this stage would ensure that the existing AI services and the existing AI products or the existing AI implementations are updated with the not only with the state of the art tools and technologies and the monitoring systems, but also with uh, with the new implementations possible. So the use case example they're seeing over here on this through this cartoon is the use case of the chatbots. So the chatbots are the AI services or tools that are being offered to the customers for the support, let's say customer support. So these chatbots needs to be updated with the continuously available real-time new data set with the continuously uh, uh, newer set of predictions and the data-based outcomes with continuously with the models that are existing behind the chatbots need to be monitored continuously and detect for any anomalies. And ultimately the product that we're looking at, the chatbot, is now able to be is retrained, reconfigured with the updated, newer, and anomaly proof implementation altogether. So we see that there are multiple stages in which there is going to be continuous learning, improvement, and training of the AI systems with the updated data, which is the core mandatory implementation for any given AI system at any given time. And this part we've already studied, that the data is mandatory under correct frameworks, rules, regulations, and data governance frameworks for any given organization. So overall, this complete process continues at different stages for achieving long-term optimization of these models or AI systems, overall allowing the models to be performing better and better. This also reminds us that the first solution is not and the last solution. The first solution of the AI powered systems is once in place can be continuously improved over time.
Let's take a quick 5-minute break, and I'll start on the remaining topics after the break.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Welcome back, everyone. Let's continue from where we left off.
Having looked at the core inputs that go into building AI systems, followed by the examples where these AI systems really enable building strategies, and then looking at the operationalization of these strategic systems, for example, through feedback loops, and wrapping up the story with the continuous improvement that these systems need, we now come to a very important topic that needs to be discussed, and that would be implementing responsible AI, or using these AI systems in a responsible manner, which is inevitable for any organization to maintain the boundaries of humanity, and also to ensure that ethics are adopted, or the principles are adopted to cater to the related governance and compliances in a given scenario. So the first discussion point that comes up would be the ethical AI principles. The list of these principles is long and may vary from company to company, organization to organization. However, there are some core inevitable points which would be part of pretty much every framework within the ethical AI principles. So the first one would be looking at, say, for example, in the finance industry, the lending practices which have been based on the decisions from AI systems need to adopt fair practices. There needs to be the prevention of discriminatory lending decisions, because let's not forget there is data available to the AI systems, and the AI systems can process the data in biased manner, leading to the discriminatory lending decisions as one of the examples. So the financial access that a particular AI system is providing to the beneficiaries needs to be in an equitable manner. So when such systems are built, they have to be handled for any kind of biases that may lead to the discriminatory lending decisions. So this is one example which would be the part of ethical AI principles in the finance industry. Now the let's come to another example, that is looking at maintaining accountability for the automated actions. So the AI powered systems that are going to provide automated actions for the given set of tasks in any given organization, in any given department, they need to be monitored by the presence of humans, and hence human oversight is inevitable to ensure responsible outcomes and to ensure the non-violation of the practices and to ensure the complete implementation to be well within the ethical AI principles. So overall, accountable automation, let's say in the manufacturing industry, would be another example to be included under the ethical AI principles. In the HR industry, where the recruitment is the core task, the recruitment models should not be biased towards a particular gender. So the AI systems or the AI powered recruitment systems for given HR departments in any organization should be audited for the non-biased recruitment pipelines rather than any unfair practices based on gender bias being adopted, maybe intentionally or unintentionally. So this is another example which needs to be audited for ensuring that ethical AI principles are in place. Transparent reasoning is another core outcome which should be mandatory for AI powered systems to have in place explainable outcomes, and the explainability should be as transparent as possible. As much details should be revealed about the implementation of AI systems as much as possible, so that the audit teams and auditing stakeholders are able to ensure that the existing systems are under the ethical AI principles, or else they can on get the experts on board to ensure that if there are any kind of intentional or unintentional violations, then that can be handled as per the regulations. The last example, of course, auditing. Fairness in auditing is another example which is part of the core ethical framework. So auditing algorithms for AI systems, auditing algorithms for, let's say, general systems existing in the organization, let's say taxation, they should be they should be handled in a way that they are being monitored or audited for their compliance to the ethical AI principles. So continuous monitoring of existing systems and auditing of existing systems within the organization, be it AI-based systems, be it non-AI-based systems, fair auditing needs to be performed, ensuring that the ethical AI principles are served well. So the responsible AI involves timely auditing, fair auditing, non-biased implementation, accountable automation, zero biases towards or favoritism towards a given gender for recruitments, etc. All these serve to be the examples of the implementations of responsible AI systems. Another area where the responsible AI implementation is critical is privacy and compliance. First practice would be to adopt AI data encryption. The customer data on the e-commerce platforms, on the financial banking platforms, all the examples we've studied, on the content related platforms like Netflix, or on the social media like platforms like Instagram. So the customer data should be well encrypted when it is being processed through the AI systems or AI engines for deriving insights. So let's not forget that our ultimate goal is to derive insights from AI systems which are banking big time upon the data, input data. So the input data, which is typically the customer data, and even if it could be patient data, it could be other data sets, they should be encrypted while being processed in these AI engines. Another example of privacy and compliance adherence would be the GDPRs. So the general data protection regulations need to be followed. These guidelines, these rules need to be followed for the data rights of the consumers, users, stakeholders for any platform, any domain, any area which is empowered or which is powered by the AI engines. Another one would be a very critical one, which is role-based access. So once the AI systems are implementing the user data or sensitive data like the credit card information, or let's say financial information or healthcare related information, that data should not be accessible to anybody and everybody. It should be highly following the rule of least privileges. So the employees working on those AI systems, the developers, the AI ML practitioners and professionals, researchers, they should have role-based access, and sensitive data should not be available to anybody and everybody working on those systems also. So this is another point that needs to be catered in terms of privacy and compliances that need to be in place in the direction of responsible AI implementation. Another example would be the anonymization protocols, where the name needs to be de-identified. Anonymization is also in the direction of de-identification protocols, where the data of the user, customer, consumer, patient, or the stakeholders need to be anonymized, de-identified in the analytics workloads. And only the features or the, let's say, the information that would help the data analytics should be part of the analytics workloads, not the identification information. So anonymization, de-identification are examples of the practices and the protocols adopted to serve privacy and compliances in the direction, again, for responsible AI implementation. The last but not the least is the human intervention that needs to be in place to ensure trustworthy implementation and responsible implementation of artificial intelligence systems. Be it the loan validation systems or the fraud alert review systems, the medical verification or medical assistant tools. Let's not forget, when it comes to the medical industry, AI tools are the core assistant tools, and the word assistant is very critical over here, as they cannot replace the medical human intervention based medical professionals being in place. So we have to look at them from the perspective of being the assistant tools, and be it the supply chain control systems or the marketing approval systems or any systems that are being powered by the AI engines. The presence of humans in the loop and the oversight, the judgments, the monitoring, the auditing is inevitable by the human intervention being in place. This allows overall building of trustworthy systems rather than the systems operating completely uh, on unchecked, completely unchecked, and not having any intervention by the humans whatsoever. So taken together, we see that there are core implementations needed to ensure responsible usage of AI powered systems. Now, having discussed the responsible usage of AI systems, we now gear towards the key drivers or uh, key contributors or the encouraging factors or the key factors help uh, that help aggravate or they help foster implementation of AI systems. So first thing would be definitely the responsible AI adoption. The complete discussion that we had in the previous slide is the first and foremost important driver that fosters the usage of AI systems across the organizations and companies. Another driver that demands the mention would be the competitive advantage that an organization gains after implementing these powerful AI systems. For example, these predictive models, they do provide insights which can be then operationalized, as we've discussed, by the organizations to gain competitive advantage. Advanced competitive risks can be predicted. We have seen that. So the competitive advantage is a key driver that pushes the organization to adopt AI engines in their pipelines, their operations, in designing the strategies, etc. Another driver that pushes the organization to adopt AI powered systems is customer retention. Customer retention directly boosts the revenue. It boosts and encourages and fosters the business in a positive way. It brings along with it the ROIs, return on investment, and ROI increments. So overall, the customer being catered in a personalized manner, the use case that we discussed, overall increases customer retention that really powers the business very well, not only in terms of revenue and monetary gains, but also in terms of delivering satisfactory job to the customers. Next, we look at the efficiency gains. Big time. The AI systems allow the efficiency gains. But let's not forget the efficiency that is gained needs to be audited well and needs to be having human oversight. So all the operational insights and the feedback loops that we discussed that allow the efficiency gains to be in place, low latency systems with KPIs being achieved. When we say efficiency gains, KPIs being achieved like we've discussed. But human oversight is inevitable, and let's not forget that. But this continues to be a key driver for the companies to adopt the powerful AI systems. And last and the most important one would be the agility that comes along with these AI systems that brings the strategic planning into fruition and into materializing the outcomes. Overall, AI enhances the agility in strategic planning that leads to positive outcomes in the given industry. So now let's learn how these AI systems are put in place in different phases to achieve the target outcomes that an organization aims at. So we see on the screen a cartoon showing a roadmap which is staged and which shows the execution of multiple implementations at different stages to achieve AI powered systems in a progressive manner with complete value realization. Each stage has to be sequential and in a particular order as listed here. Hence, order has its importance. So let's begin discussing from stage 1. In stage 1, we see that a pilot experimentation is launched for high value AI use case. Hence, one organization may have multiple high value AI use cases. So we are not talking about one particular AI implementation or AI engine. There could be multiple AI engines that an organization is adopting. So for one particular AI engine, an AI powered system that the organization is adopting, a pilot needs to be implemented or launched. Pilot implies initial experimental stages where nothing has been finalized, but the core inputs are collected and the systems are put into place to check and see and taste the outcomes. Once the pilot stage is over, and if the pilot stage meets or shows success, then at stage 2, the scaling of the implementation is performed. Scaling would need the infrastructure. Let's not forget that AI systems are or do get implemented and work on the state of the art infrastructure systems today. So these infrastructure systems could be high budget systems and would be feasible for the scaling up to be able to cater to larger audiences, larger data processes, larger overall scenario as a whole. So scaling with robust data infrastructure investments are going to be critical in order for a business to implement AI powered systems in a successful manner as a whole. Then comes the stage 3, where once the infrastructure is prepared for scaled up AI operations, then the deployment of those AI operations is done on the given infrastructure or deployed infrastructure or the initiated or let's say the launched infrastructure. So deployment of enterprise-wide ML ops practices is performed. And when we say enterprise-wide, then where the pilot implementations in different departments was done. Now we are looking at enterprise-wide, different departments, different ML ops practices being put into place. So we are looking at the scaled infrastructure for multiple AI engines to be in place, be it the HR department, be it the finance department, be it the marketing department, for example, multiple departments that an organization would be having. And once these AI engines are successfully into place for the given department, given use case, then these needs to be continuously improved. The improvement is based on monitoring. Hence, stage 4 would be looking at the insights that are resulting from these ML ops operations, and these insights getting embedded into the use cases, implemented into the use cases with continuous feedback loops and continuous monitoring being done. And once such successful pipelines are in place, then comes the last stage where the whole AI engines in place, or set of AI engines, or set of MLOps practices in place, needs to be continuously improvised to make it better and better for all the KPIs, including accuracy, latency, etc., and continuous improvement, continuous training, continuous learning of these systems with updated data sets is another mandatory input at this stage. The goal of stage 5 is to make the systems better and better and even more powerful for the implementations that the organization is adopting for the AI based systems. So the 5 stages that we saw are highly progressive and focused on value realization at each stage to ensure that the final set of outcomes are accomplished. Hence, the roadmap for AI strategy or AI engines being developed and deployed is not a one-shot game. Rather, it is phased, or it is also staged, as we can see over here. So let's take a real world scenario to discuss the same and look at the phases in which this implementation goes through. And before we discuss the real world scenario, this phased implementation, where we discuss starting from the pilot stage to the final stages where the continuous improvements are done to fetch the continuous value. Hence, these implementations are done in continuous manner and in never ending ways. Now let's pick up a real world scenario where we would see a setup being deployed starting from the pilot phase, resulting in the transformation and the impact that it would bring in a given organization, opening the avenues for continuous improvement and ensuring that there is going to be scope for continuous improvement. So let's begin with the use case, and that use case we are taking for the real world scenario is the churn prediction. So churn prediction means, through a simple example, it can be explained that for an e-commerce, let's say, organization or a company, the churn prediction would be to predict how many customers would actually leave or unsubscribe. For a content-based organization like Netflix, churn prediction would be how many customers would actually unsubscribe the platform. So in that scenario, we are looking at the churn prediction use case. So in this real world scenario, AI engines need to be deployed for churn prediction so that strategies can be adopted at different levels: marketing, operations, investments accordingly to tune to the business aspect, and that is the churn out of the customers. So this would be performed in 3 phases. Phase 1 is the pilot phase. Phase 2 is the scaling up phase. After the successful pilot phase of a given AI engine or multiple AI engines setup done and insights achieved and operationalization based on insights performed. And once the pilot phase is successful, then the scale up of the deployments and implementations is performed by adopting the infrastructure accordingly, which is suitable and feasible for the scaled models and the MLOps or machine learning operations, which would mean the pipelines to be in place back to back. The last phase would be the phase where the complete organization gets the deployments of these AI engines in different departments, different realms, disciplines, different systems that leads to the transformation, and hence that organization becomes an AI first organization with transformational practices, pipelines, implementations, operationalizations because of the powerful AI engines in place. So let's take a look at phase 1. In phase 1, which is the pilot phase, a simple machine learning model which would predict the customers are at a risk of leaving or not. So let's understand this a little bit more, especially for the learners who are from non-tech background. The machine learning models are the algorithms, for example, regression models or classification models. So these models would take the data and make predictions. They would take the data, undergo the process of learning and undergo the process of training. And once they undergo the process of training, as you can see in this cartoon, they have taken up the data, the user data, which is processed data, clean data, high quality data given to the model, and the model undergoes the process of training, learning, and understanding the data and becoming ready to make predictions. So this model is going to start making the predictions about which customers are at risk. It is able to make predictions because it has undergone successful training with high accuracy of training, which is checked statistically by the experts and approved by the experts for the accuracy values and the credibility of the predictions that are going to be made. So this model, let's say a simple model, is successfully predicting the list of customers or the customers which are at a risk of leaving a particular uh, product or subscription or the business with which they are attached to. That is one aspect, and that is going to be prediction of the churn or churn prediction. Another task that this model can do is the insight or the information that it is going to provide. Based on that, the actions can be triggered. Downstream actions can be triggered. For example, timely notifications and updates to these customers, For example, all the actions that would allow anti-churn activities or high engagement activities. Another example would be displaying the coupons and discounts on the customers' accounts, emails, WhatsApp, etc. So the model is not only making predictions, but it is also giving insights that can trigger downstream actions to help alleviate the situation. And overall, the outcomes from this particular deployment, complete end-to-end deployment, the impact can be validated. For example, did the targeted actions prevent the customer from churning? Or did the prediction about the churn was true, etc. So the impact can be finally validated. So in phase one, it is not a scaled up deployment. It is a preliminary deployment, preliminary experimentation where complete, clean, processed data through data pipelines are fed to the model. The models are trained and models would do the work and the task they're supposed to do, and the impact can be validated at the pilot phase itself. For example, did the churn reduce, or one particular customer segment churn reduced, or customer churn in one particular region reduced because of the targeted actions in particular region were adopted in a timely manner, etc. And once the impact is validated and the whole system is operating, the frontline teams, the employees, the sales professionals, or the backend teams would receive the churn alerts with the recommended actions typically. And also the early KPIs, the indicators like churn reduction. So if this model is successfully, or this AI engine is successful at the operations it is supposed to do, then one of the success indicators would be churn reduction. And if that is being measured and observed, then this proves to be a successful AI engine in place. This also fosters the next step of uplifting and improving the whole AI engine in a continuous manner, or in other words, improving the model so that it can become better and better at the outcome which it is providing currently. So this is an example of the pilot phase where a simple model is successfully providing not only the risk of which customers are at the risk of churn, but it is also providing the actions, the targeted actions. It is also providing the alerts and recommended actions, and overall the system is also ready for continuous improvement that can be done, and uplifting of model accuracy is one example for the improvement. But at phase one, it is not a full-fledged implementation, but only preliminary implementation for quick testing, as you can see, region A. So if the company or the e-commerce website, or let's say the content-based website is serving multiple regions in a given country, then this pilot phase was launched only, let's say, at one particular region. So it is not a scaled up operation at all. It is a preliminary operation, and based on the success and failure and the final impact, the next set of actions are decided. That is, phase two is decided. So let's come to phase two. As per the roadmap, phase two is to scale up. Once the AI engine successfully deliver the indicators and the key indicators that determine the success of these AI engines and have the validated impacts reported by the stakeholders, then in phase two, these systems, AI systems, are scaled up. So this is where the infrastructure plays a big role, and cloud computing platforms are going to be playing a big role to provision or allow the infrastructure that supports the scale up of the AI systems. Next, the data sets, the data lakes would also be expanded and updated with more and more and new and newer data altogether. And overall, the complete MLOps pipelines would be expanded to take larger amounts of data, operate on the state-of-the-art infrastructure to cater to even larger number of operations and the catering at a scaled level. So the points that go into phase two would be number one, have the larger data sets, more and more data being fed to the models for better and better learning and understanding and better capabilities for making predictions. Number one. Second is to ensure the data that is being fed is high quality data and hence the right set of pipelines, scripts, and codes are in place to ensure that the data is clean and data is providing high quality information. Data may be also used to create new features. New features means new pieces of information from the existing high quality data sets and data information to make it more friendly with the downstream machine learning algorithms. So in phase two, we see that these 2 points are indicating the scaling that would be performed at the data level altogether. Then we come to the machine learning or the model or the ML ops implementation. So the ML ops deployment for continuous monitoring, retraining, and version control would be done for continuous improvements in the AI engines altogether. And once we have improved and well working models and the implementations, then the different directions of expansions can be adopted. In the pilot phase, only one region or one geographical region was having those AI engines implemented and the impact being evaluated. Now that same AI engines is scaled up to serve to a bigger geography or geographical location, not only one region A, B, C, D, E in a given geographical location, and not only cater to one particular segment of customers, but also to multiple segments of customers or users or any downstream candidates that are going to be the ones that are going to be benefiting from these AI engines altogether. Followed by this, we are also looking at introduction of continuous reporting, real-time reporting of all the outputs like churn likelihood and other insights also to the backend stakeholders of the businesses, the staff, the employees, the developers, the machine learning experts, everybody being updated with the churn likelihood insights and other information also, actions, alerts, etc. altogether. And then we gear up towards the final phase, which is phase three. Once the scaled implementations are in place, catering to multiple geographies, multiple segments of the customers, then the expansion of these AI engines to different verticals, different departments within the same organization then begins to achieve final AI engine based transformations. So enterprise-wide AI integrations are achieved and accomplished. And in these implementations, the insights that were obtained from phase 2 are now embedded. Actions are being taken in all customer facing systems, be it customer support, be it your any customer facing system, be it your sales department. Those insights are channeled for the implementation of the insights to make the businesses grow better and have the outcomes achieved in the positive directions. Also, we see that the previously adopted strategies are then transformed, redesigned because of the insights that are being provided by the models with AI driven personalized engagement plans. Remember, personalization is a big pillar of the AI driven, AI powered, or AI engine based business operations for the betterment and transformations. The tailored and customized recommendations and engagements, and rather it would be better to say enhanced engagements of the users because of personalization has been a proven game in the businesses and has also been a proven uh, successful implementation of these AI driven systems. Then we want to be looking at the proactive interventions across different domains like marketing, service, and product teams. Why? Why are the proactive interventions possible? Because of the insights that the algorithm provides. A successfully well performing model provides. Furthermore, not only are the customer facing systems, marketing and service and product teams take correct actions to rectify and do the right set of implementations, but also the product designing is also performed, and newer programs and schemes are being launched for the customers to retain them and to ensure that engagement is going to be lasting longer. And overall, every single step that we have discussed is now being taken into continuous learning feedback loop across the different AI engines and different AI systems across the enterprises for strategizing not only one department but multiple departments, be it customer facing systems, be it marketing, be it service, be it product teams, be it product design teams, be it your loyalty programs designing teams. They all are going to take the actions based on the systems existing, which are now experiencing continuous learning through feedback loops for continuous improvisations to become better and better, with sky being the upper limit to achieve the benefits and leverage the AI based strategies that are implemented across the different realms and domains of the businesses. So to summarize the entire set of discussion that we've had, the core points would be: number one, in the pilot phase, in a given real world scenario, the targeted churn prediction model is deployed to validate the impact. And if the model is having a positive impact in a limited geographical region with limited implementation, then it is taken forward for scale up to other regions, multiple workflows, multiple departments, etc. Furthermore, after scaling up, there is intense integration of insights to leverage maximum benefit from these AI-powered engines across different domains of the business at any given time. This also empowers the different teams to be proactive and take the actions in a timely manner with the real-time predictions being provided by the powerful, well-performing ML models, which are the core of the AI engine's setup. Also, the last point to wrap up our entire learning would be that the ultimate outcome is to build an enterprise-wide feedback loop for continuous AI improvement with continuous positive impacts, thereby making these organizations AI first organizations. Thank you.
Thank you, Geetika. That was incredibly insightful. Now, I know everyone's looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And while you do that, I'd like to give the presentation rights over to Ifla, our product marketing person, who's going to introduce you to some of our fantastic promotions and webinar-related courses.
Thank you, Tracy. Insightful session. I believe everyone must have learned something new today or would have been able to brush up their skills around Google Cloud technology.
So firstly, I'm excited to announce that Netcom Learning is now an authorized training partner for Google Cloud, making us your go-to destination for cloud skilling. With this milestone, we are proud to offer comprehensive training across the three leading cloud technologies globally: Microsoft Azure, AWS Cloud, and now Google Cloud. So we, Netcom Learning, is your one-stop shop for cloud skilling. I would also quickly like to take you through some of our hand picked resources, which we think will immensely help in accelerating your Google Cloud skilling journey. Well, this document here that I'm presenting has been shared with you all in the handout section of GoToWebinar panel. You can download this document and access all the resources and browse all the offerings we have curated for you. So first up is the list of our recommended courses, which we feel will best suit your learning journey after attending our masterclass. So all these courses here are hyperlinked. Feel free to go through them post-event and check out the course descriptions and prerequisites and the value it can add to you and your team skill sets. Additionally, we have curated a blend of resources, including our upcoming and on-demand events, as well as some informative and educational blogs. So you can make the most of these resources to gain extensive knowledge on the Google Cloud topics they cover. Also, here I would like to inform you that today's masterclass session is being recorded. So, in case you want to refer back to any of the topics that were covered by the trainer today, we'll be sharing the recording link with you through emails, and also you can access the link here on the handout so that you can revisit the session and learn at your own pace. Now, apart from our virtual sessions, you can also catch all the relevant updates related to IT and business training on our social media handles. So please feel free to follow us on LinkedIn, Twitter, and Instagram, and also subscribe to our YouTube channel for all the latest updates. Our official pages and channels are linked here on the icons. Finally, if you have any suggestions regarding the topics you would like us to cover in our upcoming webinars and masterclasses, please don't hesitate to send us a direct message or leave a comment on our social media posts, or you can just simply email us at google@netcomlearning.com. We would definitely try to come up with the sessions on your suggested topics. Thank you once again for joining us today. You guys have a good one. Thank you.
Thanks so much for guiding us through that information, Ifla. And now we're going to go ahead and jump right into our question and answer session. First question is, what issues may arise if metadata is not tracked properly?
There can be multiple issues that can arise if metadata is not tracked properly. One example would be the data mismatch happening and the model not getting the complete and correct information about the data set at the time of training. This would lead to erroneous training of the model, leading to downstream impacts in a negative manner. Thank you.
Second question. If ML ops grows but governance doesn't, then what impact would it have?
If governance is not aligned well with the MLOps growth, it can impact the organization in a larger way and also in more than one ways. One example for the negative impact that it would bring along is that the organization may deviate from responsible usage of AI systems, which is totally inevitable as per the compliances. Thank you.
Last question we have is, why is clean unified data important before using AI deployments?
Sure. Clean unified data is a symbol of high quality data. Higher the quality of data, better the machine learning model learning process would be, or the training process would be. And better the training, better the prediction outcomes. Hence, it is important to have high quality, clean data sets in the very beginning itself. Thank you.
Once again, I want to remind you that as you leave the session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.